Hi guys, my name is Narayan and I welcome all of you in this video. And in this video, we are gonna learn about the concept of spanning tree protocol. So we will be knowing how does it work and what are the advantages of spanning tree protocol. Basically, we talk about the switching and how does it work, what are the functionalities, advantages, and how does it goes in switching environment. So we will be learning by all those things one by one. So, and I hope this video will be informative for you at the end. So first of all, let's begin this one and try to understand the topic. So as you can see here, I have not taken anything, but if you see, I have taken the heading here: physical redundancy in an Ethernet LAN. I have not mentioned anything like spanning tree protocol. So why I have taken this heading here? Because uh, this spanning tree protocol is used if you are using this physical redundancy in an Ethernet environment, then only it is required. So we will try to understand all those things here. So first of all, if you see here this diagram, so it's very easy to understand, and if you go through this diagram and try to understand, it will make you very easy to understand. For example, if we talk about this one, so as you can see here, I have one PC here in London and I have one more PC here in Rome, which is in segment B, and this one is in different segment. So segment A, you can see everywhere I have a separate segments. uh, if you see here segment 1, if you see here, it is segment 2, segment 3, and segment 4. So everywhere we have separate segments. So we will see here how it works. So first of all, we will start from here, and as you can see here, I have four switches: switch 1, switch 2, switch 3, switch 4. So when multiple switches are implemented on the same network, as you can see here, multiple switches are we have, there is a potential for intentional or unintentional physical loop. So the main concept is here loop avoidance. We use this concept spanning tree to avoid the loop in the switching environment. If you are using multiple switches and it is creating a loop, so this spanning tree protocol will help you to deal with that looping. Then we will learn it all this thing, how it works and how to resolve this issue here. Next thing here, when loop occurs, broadcast storm may be created. So if loop is occurring, what is the meaning of loop here? The same thing is running around this all four switches. If you see here, if the signal is coming from here, it is going this way, and from here to here. And if you see here again, the same thing is coming from here. So this is called loop. It is looping, it is going around. And propagating proper propagating frames throughout the network. This topic described, तो इसी में हम इस topic में, in this topic we will learn all about all those things one by one. So the first thing here, we will try to understand how it create loop or what happened here. Adding switch to a LAN. Why do we use more switches, or why do we use redundancy, and what are the advantages? First of all, we will try to know here. Adding switches to LANs can add the benefit of redundancy. Redundancy, what is the meaning of redundancy here? Redundancy is like, if your one switch is down, the IT infrastructure should work with other switch. So this is called redundancy. You can say the backup, that is connecting two switches to the same network segment to ensure continual operational in case there are problem with one of the segments. So as you can see here, the meaning is very simple. Why do we use more switches here? See, if you have the simple thing is like, if you want to send any data from this PC to this PC, if this switch is down, still this data communication can happen through this route. So this is the advantage, or this is the main role of using redundancy, and we use this redundancy concept. So the communication should happen properly even if one switch is down. So that is called redundancy. Redundancy can ensure the availability of the network all the time. So same thing, as I told you, if we use the redundancy, if one switch is down, still your network will be available. However, when switches are used for redundancy in a network, there is a potential problem of loop. So The thing is, if you use more switches in your network, there are lots of chances or more chances of loop creation or loop may occur very oftenly. When a host on a network segment transmit a data to another uh, host to a host on another segment. For example, this is in segment A and this is in segment B, and this host is trying to send data to this host Rome, and the two are connected by two or more switches, and both are connected by two switches. Each switch receive the data frame, looks up the location of the receiving device and forward the frame. So the thing is like this switch will receive the data and it forward to this side and this side as well. So this is how it loop. There will be chances to occur the loop because it is going uh, from both the ports and it doesn't know where it has to go. But the thing is like the destination is here, but it will not decide how to uh, send it, because the data this switch will be in problem because it will receive data from both the side, from this side as well as this side, because each switch forward the frame. There is a duplication of the data. See, the same thing is happening if this switch forward data to this side and this side, so there will be duplication in the data. Same data will be coming from this side and same data coming from this side also. This process result in loop and the frame circulate between the two paths without being removed from the network. And the same thing will happen without removing from this switch and this switch. Once it comes to this port, the data will be forwarded to this fourth switch. The MAC address table may also be updated with incorrect address information, resulting in inaccurate forwarding. So the same thing will happen because once this switch receive the data from this side and this side, it will receive same data from both the ports. So some problem may occur here in a MAC address table. Example we will see here, one example to understand in better way. See, for example, suppose that a host named London send a data frame to host Rome. Okay, so we will take this. I have London here and it is sending data to Rome. London resides on network segment A. Okay, and the Rome is on segment B. As you can see here, we have A here in segment A, London, and segment B, Rome. Switch A receive the frame destined for host B and flood it out to switch 2 and 3. So the same thing as I told you, this switch is receiving data and it is flooding to switch 2 and switch 3. Both switch 2 and switch 3 receive the data frame from London via switch 1 and correctly learn that London is on segment 1 and 2 respectively. What does it mean? See, it is receiving data this switch 1 and it is learning that where data has to go, segment 1 and segment 2, because 3 is this side and 1 is this side. Each switch forward the frame to switch 4. Now this switch second and switch third will send the same data to switch 4. Now what will happen here? Switch 4 receive two copies of the same data from London. So this switch is receiving same data from two copy of the same data from switch 2 and switch 3. What will happen now here? Switch 3. Let's assume that the frame from switch 2 arrive first. Switch. Now what is happening here? This switch 4 is receiving data little faster from switch 2 as compared to switch 3. So what will happen? Now this switch will immediately forward this data to this device as well as switch 3, because it has not received data from switch 3. There is a little delay from this switch 3. So it will forward the same data this side and this side. Now after it has this switch 4 has received the data and send the data to 3 and this host B or this segment B or Rome system. Now after some time this switch 4 has received the data from switch 3 also. So what is happening here? And the same data is going to be forwarded to switch 2 and segment B, ROM PC. So it is what is happening, the same data is circulating throughout this circle. First it came from here and it forwarded to 3. Now 3 has sent the data to 4, and it has now this 4 is forwarding the same data to switch 2. So this is how the loop is occurring here, and the same data is going twice to this ROM PC also. So same thing is mentioned here also. Switch 4 learn that London resides on switch 3. Since switch 4 does not know ROM's address, it forward the same frame from switch 2 to ROM and switch 3. So as I told you, this switch doesn't know where it has to go, so it has flooded or it has broadcast all the ports. So it is going to switch 2 as well as switch 3, whichever data is coming from here or whichever data is coming from here. The data it is which is coming from 2, it is going for 3 as well as segment B, and data which is coming from data or frame 3, it is going to switch 2 as well as segment B or ROM. When the frame from switch 3 arrive at switch 4 updated table to indicate that London resides on 4. It then forward the same to ROM and switch 2. The same thing as I told you, when it is receiving the data, it is knowing that the data has to go here, and it forward to 3. And when it receive data from 3, it forward the data to 2 and 3 and update the table here. So it is creating duplicacy of that frame here. Switch 2 and 3 now change their internal table to indicate that the London is on segment 3 and 4. If we talk about 3 and 2 and 3 switch. So if we see switch 2 and 3, they are updating their table by the information which is like the segment 4. So what is happening here now? This switch 2 and 3 is updating information about this segment. This London is in segment 4 and 3. So it is completely incorrect information, and it is misleading to both the switches, because London is in segment A, not in segment 2. I mean segment 4 and segment 3. So this loop is creating incorrect information and updating to the switch 2 and 3. If the initial frame from London were a broadcast frame, both switch would forward the frame endlessly using all available network bandwidth and blocking the transmission of other packet on the both segment. This this situation is called a broadcast. So what is happening here? So now what will happen, this these both switch will forward the data again to this switch 1 and this side. So this same data will be traveling across the network, and this is called storm, broadcast storm. So we will know more about this thing in next slide. Look here, now the concept is coming of spanning tree. So how it resolves this looping, and how it is useful to avoid this loop occurrence and this incorrect information traveling across the network, or this creation of loop, or how to avoid this broadcast storm by using spanning tree. So we will learn here. As you can see here, loop resolution with spanning tree protocol. Okay, so spanning tree protocol is means to resolve loop in redundant network. Same thing, as you can see here also, it is also a redundant network. This topic describe how STP functions. So we will understand here how it works. So as you can see, again here we have one PC here and one PC here, and again 4 switches. Okay, the solution to loop is STP. So whatever we have seen in previous slides, so and whatever problem we have understood, to resolve all those problems we have STP concept here, which manages the physical path to given network segment. So it will manage this segment to physical connection. STP provides for physical path redundancy. Again, it's a concept of redundancy, and if you are using redundancy, STP will be there. How it prevents? STP provides for physical path redundancy while preventing the undesirable effects of active loops in the network. STP is on by default on catalyst switches. So if we talk about the Cisco switches, it is enable by default. We do not need to configure it manually, but still we can make few changes if required. We will see later on. So the thing is here, you should understand. See, we have one root switch here, and one more switch here, one more switch here, and one more switch here. Okay, so as you can see here, it is mentioned root and it is mentioned B. So we will try to understand what all those things are here. So a tree like loop free topology is established. So this is, if you see here, the color of this connection is little, I mean two color, yellow and red. So this is a as you, if you can say it's a proper connection, it's a redundancy connection. But if you see here, one cross is there and this is a red line. So we will try to understand, and this is how STP work here. Okay, so we will see here STP forces certain port into standby. So this is the concept of STP. It will put some ports into standby state. So they do not listen to forward or flood data frame. So this is the concept of spanning tree. This much only enough to understand what is the concept of spanning tree. The concept of spanning tree is it puts or it keeps few ports in standby mode. The overall effect is that there is only one path to each network segment active at any time. So this is how the concept works here, and we will learn in more depth in next slides. If there is a problem with connectivity to any of the segments within the network, STP will reestablish connectivity by automatically activating a previously inactive path if one exist. So this is how the concept is. See, the thing is like, if I tell you in very simple word, the concept of STP is it will put one port in standby mode, or you can say this in silent mode. I will take example here. I will show you how you will understand. We will take two switches here. Okay, so I'm taking two switches here, so you do not need to go through lots of this thing theoretical part, and you will understand the concept of. So I'm taking crossover cable, I'm connecting two switches. Okay, so this is also again a redundancy concepts, because I have taken two switches and connected through two cable. If I have a PC here, you can say laptop or PC, whatever, and both are connected to port 3, this one, and anything you can take here like this. So if this PC want to communicate through this, if this PC want to communicate to this laptop, it will go through this path only. If my one cable is down, which is port 1 01, it will go through port 02 for fast ethernet 02, and communication will happen. But the thing is, the concept of redundancy, this is called redundancy. If one cable is down, or one port is down, still the communication will happen. But if we are talking about the spanning tree here, spanning tree protocol, how does it work? So as you can see, the concept here itself, as I told you, it will keep one port in standby mode. So they do not listen to forward or to flood data frame. So this is the concept, how it goes here. As you can see here, we have ports here, 1 2 3 4, to forward the data for this communication. But if you see here, only 3 ports are active. So this port number fast ethernet 02 is in standby mode, and it will not come green because it is in standby mode, and this port will come green once one of the rest of 3 port is down, or one link is down. If I remove this cable, this port will come up immediately, and then only this communication will happen. Or if I restart this switch, just let me power on, it is already. So now this communication will happen. If I reconnect one more cable, so it will keep one port in standby mode. So this is how STP work here, the concept of spanning tree protocol works. And there should not be any confusion, and there is no any chance of confusion. It should be very clear. This port which is in standby mode will not forward any data this side. So again, as you can see here, one port is in a standby mode. So this is how spanning tree works, and this is the concept of spanning tree. So we will learn few more things here. See, spanning tree operation. This is the very important to understand, and we should be aware about how this why this port got in standby mode. We have four port, but why this one only, fast ethernet 02? Why not fast ethernet 01? And why not this fast ethernet 01 for switch 1? Why this one only? This is a specific port. Why it got in a standby mode? So we will understand here, and this is a very good to understand and good to know, and which is called which is known as spanning tree operation. So the first thing here, uh, one root bridge per broadcast domain. If this spanning tree is operating in switching environment, so first of all, to avoid this loop, or to maintain this network loop free, it will select one root bridge. Okay, as I told you, we have one root switch here, this one. Second thing, one root port per non-root bridge. So this is second. I will tell you here what does it mean. And one designated port per segment. Okay, as you can see here, uh, if we talk about, this is a switch X. Okay, so as you can see here, it I have taken it like root bridge, and this is my designated port, and this is also designated port. I have two port here, and if you take if you you can see here, it is a 10 ways T, and this is a 100 ways T, and this is called cost. Actually, I will tell you in separate video uh, what does it mean. They have some certain numbers for that, for this 100 ways T and 10 ways T. And this is my root port means this second one, and one designated port per segment means this is a one separate segment, and this is a separate segment. So I have one designated port here this side, and one designated port this side, and it will be of your root bridge only. Okay, and if you see here, this switch B, if you see here, it is a non-designated port. This one is designated and this one is designated, and the most important thing, if you see here, it is a cross. So this port will be in standby mode, the way we have seen here in switches, two switches. This is a standby mode. So in this scenario, this port will be in standby mode. And how it works, and how this operation happens, we will see here. Okay, so here we have three step. Spanning tree performs three step to provide a loop free logical network topology. तो जो हमारी topology whichever we have or whatever we have, if we want to keep it loop free, it will follow three steps. So the first step, as I told you, it will be root bridge. So how it will calculate, or how it will consider the switch, or how it will select the one switch, and which will be your root bridge from out of four switches. If you talk about, so why this is only, why not this one? So we will see here what happens. Elect one root bridge. Okay, this is the main work here, selection of the root bridge out of four switches. STP has a process to elect a root bridge. It will follow one process to select a root bridge. Only one bridge can act as the root bridge, only one. Okay, out of whatever you have, 10 or 6 or 11, or numbers can be more. So only one bridge, or you can say the switch will have root bridge in a given network. On the root bridge, all port are designated port. I told you, if we talk about this one, so both ports are designated. If we have one more segment here, so this port also will be your designated port. Designated port are normally in the forwarding state. So this is a root bridge. All port will be in forwarding state. If I have a PC, so it will forward whatever frame is coming from, or whatever data is coming to this side. Okay, because the main functionality will happen from here, because it will give you the direction where the data has to go. So both port will be in designated and ready to forward the frames. When in the forwarding state, a port can send and receive. अगर हम if we have the ports in forwarding state, it can receive and send the data or frames or traffic, whatever it is. In this picture, X switch X is elected as a root bridge. As I told you, this switch X is selected as root bridge, and both the ports are in designated port state. Select the root port on the non-root bridges. So non-root bridge means what? We have other switches, like if we talk about this one, this is a non-root bridge, because root bridge is this one. We got this one. STP establish one root port on each non-root bridge. So it will establish one root port in every, if you talk about here also, so it will create one root port, okay, in every switches. The root port is the lowest cost path from the non-root to the root bridge. As I told you, it uses a cost to reach from here to this root bridge, or from this root bridge to this switch. So like if I talk about, I will show you in separate video for this. I'm just telling you, for example, I'm telling you here, for this 110 ways, like base, like one is cost. So one is here, or if I talk about this 10 ways T, for example, it is 10. So the one is lowest, so this port will be root port, not this one, because the cost is 1 here for this 100 ways T segment. This 10 will not be selected as, or this port will not be selected as root port, because the cost is 10 to reach this root bridge from this side. Root port are normally in the forwarding state. If we talk about root ports, they will be remaining in forwarding state. Spanning tree path cost is an accumulated cost calculated on the bandwidth. As I told you, this is, if I talk about this, this is my 10 mbps and this is my 2 mbps. So every there are certain parameters for 2 mbps, what will be cost and what will be cost for 10 mbps. I will tell you in next video. Okay, so in this figure, the lowest cost path to the root bridge from switch Y is this one, through the 100 ways T fast Ethernet link. So that is why this port got selected as root port. Select the designated port on each segment. Now we have to select one designated port also on each segment. Segments means what? This is one segment and this is a one segment. So we have to select one designated port also. How it happened? On each segment, STP establishes one designated port. The designated port is selected on the bridge that has the lowest cost path to root bridge. So the thing is here, the designated port is selected on the bridge that has the lowest cost path to the root bridge. And if we talk about the state of designated port, they will be normally in forwarding state and forwarding traffic for the segment. In this figure, if we talk about this example, the designated port for the segment is on the root bridge, because the root bridge is directly connected to both segments. The 10 ways T Ethernet port on the switch Y is the non-designated port, because there is only one designated port per segment. So I will try to understand here. See, for example, from here, if we talk about, or this side, So the thing is here, if we talk about in this figure, the designated port for both the segment is on the root bridge, because the root bridge is directly connected to both the segment. If we see this picture, it is very clear. This is one segment and this is one segment, and both the segments are directly connected to this bridge. So this port will be as a designated port, and this port will be a designated port if we talk about this segment and this segment. And the next thing is here, if we talk about this port is in non-designated state, because the reason is here, the 10 ways T Ethernet port on switch Y is a non-designated port, because there is only one designated port per segment. So already we have two designated port for both the segments, and if we talk about this segment, so we got one designated port here. For this segment, we got one designated port here. So we cannot have one designated port here and one more designated port here. And we have selected this port as a root port. So the next port will be your non-designated port, which is crosshair, or which is a you can say in standby mode, or the name of this port is non-designated actually. Same thing is mentioned here also. No, if we talk about the non-designated ports are normally in the blocking state to logical break. The loop topology, when a port is in the blocking state, it is not forwarding traffic but can still receive the traffic. The thing is, as I told you in previous previous one here, or in any picture, you can see, for example, here itself, if any data is coming from this side or this side, so if this port is in blocking state, so it will not forward any data this side, but it will receive the data. So it will come to know if anything happen, if the switch goes down, so it will come to know what is happening across the network. So this is how spanning tree works here, and how this loop avoidance we can avoid, or how does this spanning tree protocol works. For example, as you can see here, it is very simple. Now if any data is coming from here, and here, this is my B here and sending from A, so it will not go to this side, it will directly go to here, or again, so yes, it will not go, so a loop will not occur. So this is how spanning trees works. And guys, this much only in this video. I have this video will be informative for you people, and you will come to know the operation of a spanning tree and the function of this spanning tree, how it works and how it avoids the loop in the network. And for more videos, you can subscribe my channel. My channel URL is mentioned here, and from there you can know the videos of CCNA as well as MCIDP, and I have uploaded couple of videos of Server 2016 theoretical as well as practical. And please subscribe my channel and like and share it, so that there more people can reach it and they can also learn. And keep watching the videos, and thanks for watching for this video, and wait for my next video. Thank you. Bye bye.